Then again, a warm welcome to this evening or afternoon session, wherever you are in the world. We are going to do these things probably more regularly now, where we are just showing you are in the world. You can hear me twice because that's YouTube in the background. And so we're actually going to do this more often going forward, where we are really just giving an introduction to what we're building at Humanitec and the products, and in particular, obviously the platform Orchestrator. In this session, I'm going to give a quick introduction. What is platform orchestration, and why have we actually redesigned or taken a step back and designed this complete new version 2, actually, which has been in the making for a while, and I'm really excited about it and really happy. And so that is definitely something to celebrate, and it's looking really, really like people enjoy it a lot. So that's great. Yeah, so let's actually get started with that. So why do you have a platform orchestrator? And I don't want to bore you with too much theory, but that's here the like a classical example of a reference architecture if you're building an internal developer platform. And I like to think about platforming in like I'm thinking about constructing or architecting services or applications in that they have front ends and that they have back ends. If we look at here, what do we see? We have the essentially IDE or coding agents. That's where the developer interacts with our platform. We have our thing that allows us to have a view inside of the platform. That would be our portal. In this case, we have port here in this architecture. We have our version control, and then we have our what we call integration delivery plane. That's our CI pipeline, the registry, and we have the orchestrator, and then we have the resources here, and then we have the observability components. And so the orchestrator is a logic handling component in our platform architecture, a back end, so to speak, that allows us to codify rules, especially for the usage of infrastructure. We want to get to a point where we have shareable and standardizable templates that developers can pick from, and that we as the platform engineering team can also maintain over the life cycle of those resources. And we want to get to a point where we set sensible abstractions. And if the developer then says, I need an S3 bucket for my environment, for instance, they should not have to mingle with Terraform and create the 501st version of an S3 definition in Terraform. They should not need to wait for another human being to do something over Teams, Slack, or Jira, or a ticketing system. They should not have too much cognitive load. They should need something, and the platform should be able to give it to them in a way that they can actually trust that it's following the policies of that organization. And that's exactly what such an orchestration system does. It's essentially, let's look at this picture. It's taking the abstract request from the developer. I have a workload in a given form. I need a Postgres database. I need a DNS. They send that request through whatever interface. That's really important. Interface agnostic, could be the portal, could be the IDE extension, could be Claude Code, could be whatever. And they send that through the CI pipeline to the orchestrator. The orchestrator looks at, what user is sending this, what are they allowed to do, in what environment are we currently deploying to, by looking at the tags, for instance. And then it's picking up the right rules provided by the platform team. And those could be codified in Terraform, for instance. And then it's taking this and it's actually going off, creating the infrastructure components, wiring everything up, and then returning this to the developer so they can put this, wire this to their, inject credentials in their Helm charts, wire everything up, or do that through the CI pipeline, and then we can push this. So it's sort of a logic handling component in the back end of a platform. And it leads to, first and foremost, a clean handover point between those two parties, a high degree of standardization, a high degree of structure, and real scalability and security. It's used by government organizations, by high security cases, and fast-moving organizations alike. Yeah, so that's basically the idea of a platform orchestrator. Now, we've been building orchestrators for a long time. This is my 8th year now building platform orchestrators. And if you look at that, you might wonder, why are we now doing a full rebuild? Well, if you look at the first version that we've built, it was very much focused on Kubernetes. So you could only use this for Kubernetes-based workloads. You could only use this for full Kubernetes estates. It was very much tied to the Kubernetes API and was very intrusive. It took over the deployments. It took over the generation of the application configurations with baseline Helm charts. And so it really meant that you needed to rip out a lot of the stuff that you had built and put all of this together again. And if we are looking where the world is going, there are those people that are hardcore on Kubernetes and that are using, the Kubernetes API to do everything. If we look at this from what the organizations at scale really need, you can do everything through the Kubernetes API, but you're bending that concept a lot. And so we really took a step back and said, like, if we develop an orchestrator with everything that we know now, how would we do this? And the new orchestrator is completely compute and resource agnostic. You can use this for VMs, you can use this for serverless, you can use this for Kubernetes, for any type of DNS, database, whatever. And that really allows you to retrofit this into brownfield setups, because the reality is you won't go in and you rip everything out and then you replace this or build it from scratch. The estates you're all running are too large and too mature to do this, and the new orchestrator fits in really nicely with that paradigm. It also remains interface agnostic and API first. It works really well. I've just recorded a video with a vibe coding setup, for instance, and that sounds strange, but it works really well to expose this to something like Claude Code or other coding agents, to then have them or allow them to add infrastructure by just putting a request against the platform orchestrator and say, I need an S3 bucket, and the orchestrator can give you that policy compliance. So that's something that works super, super well. Yeah, so the new version here, significantly less intrusive, highly simplified, can soon also run on premises, has a very enterprise-ready security posture, is multi-compute, works with all resources, works with Terraform natively, and that's also something that Toby has worked a lot on, a highly simplified conceptual model. The learning curve is much, much steeper. Not that many fancy new concepts or terms that you need to learn. It's really a good piece of technology designed to fit into your tool stack. Yeah, and with that, I'll shut up for now, and I'll let Toby take over here and give us a in-detail walkthrough. And I think, Toby, people can also follow along later, right? You're doing one of our tutorials, is that correct?
That is correct, and I have been sharing the wrong screen. I should be sharing this one. There you go. You should now be seeing my browser. Yes, we will be walking through a tutorial which is public as part of our developer documentation. That is the nice thing about today's session, because you'll be able to replay everything we do today in your own environment. You will receive the link in the follow-up communication, and all you need to do is follow that link. You will be taken through our developer docs on develop-by-humanitec.com, and you'll be finding this tutorial, which is aptly named Get Started. It takes you through the core setup of getting the orchestrator up and running, basically from scratch, like from having nothing other than a cloud account. That is a prerequisite that we have. So we currently require you to have either an AWS or a Google Cloud account to run your resources in. Microsoft Azure support is on the roadmap. We're also thinking about a local machine version of this setup if you do not have access to a cloud account, but that is things still to come. Today, we'll be walking through the AWS track, but feel free to use Google Cloud as well, if that is your favorite environment. So this will get you started. I've given ourselves a little bit of a head start because I've set up some demo infrastructure. If you look at the agenda here, there is some demo infrastructure which will be set up for you using some prefabricated Terraform or OpenTofu code. We're going to skip that for now because it takes a long time. You don't have to watch me spinning up things for 10 minutes. So this is already done, and we will start by actually setting up the Terraform provider for the orchestrator. Real quick, to give you another little deeper look into how the orchestrator works and what we're going to, how the orchestrator works and what we're going to do today. So basically, what you do when using the orchestrator is that you serve two personas at the end of the day. One persona, which is often called a platform engineer, or an organizational admin, or a cloud team member, will be charged with configuring the orchestrator. Configuring means they will set up all the things that are required to create deployment targets at the end of the day, to instruct the orchestrator to say what are projects, environments that people can deploy resources into, and instruct the orchestrator how it's going to go about that by providing the proper code for that. And the second persona will be someone who is usually a developer or an automation, a CI/CD pipeline, that will then go ahead and use that configuration to actually deploy things, to create deployments in the orchestrator. And what the orchestrator does is every time it needs to execute a deployment, and that's a very important core concept that we're going to see a lot in the next couple of minutes, is that it launches a runner. And it launches a runner in your own infrastructure. Runner is kind of a task. It's a temporary thing. It's being launched. It executes code, and it stops. And it returns to the orchestrator. And the code it executes is either Terraform or OpenTofu code that you provide. Those are your modules that you can bring in to instruct the orchestrator to say, how do you provision a Postgres database, an S3 bucket, a DNS entry, all the sort of things you want to make available to your developers. And the end result will be that in your own infrastructure, you will have any mixture of workloads, whatever they may be, or some other infrastructure resources, or just one of the two. So that's the core concept of the orchestrator. And let's go back to the tutorial and get started. So that's the first step. We're going to start by creating a runner. A runner runs in your infrastructure. And for this demo, we will be using a runner which is called the Kubernetes Agent Runner. Kubernetes Agent Runner, as the name implies, runs on a Kubernetes cluster, and it polls the orchestrator for deployment requests. That is one flavor of runners. We have a whole range of them. Kubernetes is one. There's also the option to run a runner on ECS if you're on AWS. And we'll be providing a lot more options for running those runner components, especially on serverless infrastructure like Google Cloud Run or Azure Container Instances in the future. But now we're using the Kubernetes agent, but that is not a requirement. You can use any of the others as well. So let's get started. The runner needs to authenticate. So we'll create a key pair first. So we now have created two keys, a public and a private key, which we're going to need to install the runner. Now, to do this configuration of the platform orchestrator, you basically have two options. One option is you use our CLI tool to create all the configuration objects. That is very nice to do quick one-off commands. However, for a more permanent maintenance of your orchestrator estate, we recommend you actually use a Terraform or OpenTofu to do that, because we have our own platform orchestrator provider that you can use to configure all the Platform Orchestrator objects in your estate. So you can basically, if you have a Terraform or OpenTofu estate today, you can just add in all the Platform Orchestrator configuration to that estate and continue and start maintaining it. So we will go ahead and start with this. So this is our core. So we have a small amount of Terraform code here. This is our provider configuration, and this is our provider definition. Platform Orchestrator, this is the name of it, and that is where we start. So we'll now go ahead and extend that code. Because we will be installing the runner on Kubernetes in this example, we will be needing additional providers. In this case, it's the Helm and the Kubernetes provider. The agent itself is installed by a Helm chart. We're also going to set up some supporting objects on the cluster to help the agent run, like Kubernetes secrets, a namespace, and all those kinds of things. And that is the code that is prepared down here. So we're going to copy that code into our orchestrator estate. Let's quickly go over it, but we're not going to go into all the details because we don't have time. But just really quick. So this is the Platform Orchestrator agent runner object itself. This is using our provider, our TF provider, to install a Humanitec Orchestrator object with a particular configuration. This basically tells it where to find its key file, which namespace to use, which service account to use on the cluster. This is already being prepared as part of the core setup that we skipped, or that are already prepared, and a state storage configuration, because at the end of the day, the runner will execute some Terraform code or OpenTofu code, and it needs to store state somewhere. So the runner gets some instruction where to store state. In this case, we'll have it's a very simple setup, and it will store state in the Kubernetes cluster itself. Not a very production-ready setup, but one that is very easy to create for this demo purposes. So I'm going to save that and go back to our tutorial flow. Right. So let's do tofu init and tofu apply. So we will now start actually setting up our environment. I'm using OpenTofu. You can use Terraform. That is your choice. So it's now creating all the Kubernetes objects. It's creating the agent runner in the orchestrator, and it will now install the Helm release. There you go. The Helm release on the cluster. This is going to take a minute. While we are here, let's move over to the orchestrator itself. So the Platform Orchestrator has its own web interface. We call it the console. It's available at console.humanitec.dev. If you register for an orchestrator organization, this is where you will go to see what's happening. We now should already see, right, we already see now that there is a new runner that has been provisioned. It's called Get Started, and it was created just now. Cool. And if we look at the configuration, this is basically what we saw earlier. So this is the information where to launch jobs, where to find its keys. And there's also another thing, which are the rules. There's no rule yet. We're going to add that in a minute. But the rules essentially say when to use which runner. So if you deploy to a particular project, to a particular environment, the orchestrator has a rule engine that tells it when to use which runner. Right, so that step is now completed. So let's go back to our tutorial and continue. I've been mentioning the deployment target a lot. So what we have in the orchestrator is a concept that resonated very, very well, even in the first version of the platform orchestrator, and that is people like to have a kind of a home for their projects or for their applications. So we have the concept of projects and environments in the orchestrator. A project is just anything that you want, which is a home for a particular team or an application of a team that you want to administer. And the project is being broken down into any number of environments. Typically, there will be a development environment, there may be a QA environment, a production environment, a staging environment, like temporary environments in between. But this is kind of the concept. So the next step for us to configure the orchestrator is to create at least one project and at least one environment in that project to have this deployment target so that the runner can do its work. And that is the next part of our code. So we now have the project, the environment. So let's add that to our code, save it, go back and perform another apply. And that will now create more configuration objects in the orchestrator. That was very fast. Let's get back to our runner. If I refresh the view now, we will now see that there's a rule that has been created. And this rule says when to use which runner. This rule is very, very simple. It applies to the project ID, get started, and it essentially says, use this runner anytime a deployment into the project get started is being performed. And we also have the project itself. So here's our new project get started, created just now. It has one environment called development. If I go in here, nothing yet has been deployed. This is something we're going to do next, right? So this is the deployment home, one project, one environment. Cool. So let's continue. Next, we have to instruct the runner to actually to instruct the orchestrator to actually deploy things. Things can be just about anything, really anything that you can provision through Terraform or OpenTofu. As long as there is a provider for it, you can deploy it via the orchestrator. It can be an application workload, it can be a container, it can be a zip file that you upload to some serverless runtime. It can be infrastructure resources like databases, caches, DNS entries, all of those things, as long as there is a provider for it. This example is a very classical one, which is to deploy an application workload, which is a container that is using a Postgres database as the background. But for your case, it can just be anything. The instructions of how to provision a particular type of resource are bundled in what we call a module. That is kind of the same concept that you know if you're familiar with Terraform OpenTofu. We also have modules which are like encapsulated pieces of code that instructs the tool to deploy things. And that is basically what it is. A module is just basically just a wrapper around some Terraform code that you may already have. And what this module does in the orchestrator is that it instructs the orchestrator where to find this code and how to apply it. There are a few more concepts like resource types that we are using to classify things, but we're not going to go into those details today. The most important thing is this one. This is the platform orchestrator module for a Kubernetes-based workload. And what it essentially does is it wraps the code, it wraps Terraform code that it finds externally. So if you have your Terraform modules maintained in some Git repository, which chances are you do, this is how you go about bringing it into the orchestration. You create a module, and as part of the module definition, you basically just link to the module source code. In this case, it is a public repository on GitHub but it can obviously also be your own privately hosted GitLab or CircleCI or some other Git hosting tool instance that you run in your own organization and that is not publicly accessible. You have the chance to place parameters for this module, which will be mapped into the input variables. And that's basically just it. That's what a module does. So let's install this module into the orchestrator by adding this code to our estate, save it, go back to our instructions and do another tofu apply. This should be pretty fast again, because all we do is create some configuration objects. Nothing has been deployed yet, right? But we're approaching this point. Right? Bear with me for just a minute. So what we now can do is query the orchestrator for available resource types. So what can I deploy now? And if we ask it, what can I deploy into the development environment of the Get Started project? We get the, okay, dear user, you now have the option to deploy resources of type Kate as workload Get Started. Cool. So that is what we just instructed the orchestrator to do. So let's do it. Let's actually deploy some stuff. Deploying is done by defining an abstraction of what I want to have through what we call a manifest. A manifest is just a YAML file, which in our example looks like this. It describes a set of resources and the kind of resources that you want to provision. In this case, we say, hey, we have a demo app, and the only resource in here is a demo workload, and it's of type Kate as workload Get Started. If you may recall, that is exactly the type that we just instructed the orchestrator to handle. And as a parameter, this resource type also exposes which image we're going to use. This is a demo image that we'd like to use. So let's go and deploy this manifest. I'm going to switch the directory. We have the manifest prepared already right here. So that is just the same manifest. So let's go ahead and finally perform a deployment. Copy this command. So we're going to deploy to the Get Started project and the development environment using the manifest1 YAML. Let's say, hey, no previous set for deployment. So that is the first one, and it will add this workload. Great. This is going to take a minute. Remember, what's happening now is that we are now at this point. We have previously instructed the orchestrator how to provision a module of type K8 as workload. We also have provided a deployment target in terms of a project and an environment. And now we can finally do this deploy step. And what's currently happening is that the orchestrator launches the runner, in this case on our Kubernetes cluster, because we use that type of runner, and it will deploy that manifest according to the instructions that we left earlier on through the module. Cool. So this is finished, and we should now see, if we refresh our view in the console, right, we should now see that the deployment has been successful and a small graph of all the resources that are part of that deployment. It's not very spectacular yet. This is just the logical wrapper workload, and this is the actual workload on the cluster. But we get some information right here. We see that, okay, this is using a Kubernetes deployment called Get Started, using this image, and it's deployed into the default namespace. Cool. Great. So that worked. That is stage one of our deployment approach. We can now go ahead and inspect the workload, but we're going to skip that, looking at the time, because we want to finish on time as well. So just believe me that there is now a workload running on the Kubernetes cluster that we could access. Just real quick, let's do a Kubernetes get deployments into the default namespace, and you will see that there's the get started with one pod ready. And that was just created 2 minutes ago. Splendid. So now let's do something a little more fancy. Let's extend the estate and add a database to the deployment. We are using a Postgres database, and for the AWS case, it's going to be an RDS instance that we're going to provide. So remember that we now have to provide another module for that database to tell the orchestrator how to provision a Postgres. So let's go back to the orchestrator directory and add some more code to our estate. So the first piece of code is another resource type, which is the abstract definition of our Postgres. So this is the schema of a Postgres database in our world. Then we're going to add the actual module. And we're also going to add a provider that we will inject into the deployment. The provider is just what it is in the Terraform world. It will be translated into a Terraform provider, and it will instruct the runner to configure its own TF provider. In this case, it needs to configure the AWS provider to provision this RDS instance. This is very simple. We're using workload identity setup on the clusters, so there is no further configuration required for this provider. So this can be kept very, very simple. Cool. Let's save that. And let's add another module rule that tells the orchestrator when to use that module. That was the wrong target. There you go. Cool. So we now have expanded our estate. So let's apply that. Again, no deployment yet. This is additional configuration that is being added to the orchestrator now. So if we now query for available resource types again, we will see that we are now able to deploy those types of things. We can now deploy an AKS workload, and we can deploy Postgres database. Cool. So the last thing to do is go back to our manifest directory and expand the manifest. Expand the manifest in this way, where we prepared this. Same manifest as before, but we now have a second resource. And the second resource is a DB of type Postgres get started. And that is literally the only thing I have to do as a developer at this point to actually request this Postgres database. I do not have to know where it's running. I do not have to know anything about AWS. I don't have to know about RDS, about the configuration settings of my database. This is literally just those 2 lines that I have to add to say, hey, I want a database. And by the way, we can do another nice thing. We can have this resource provide some outputs to its workload to populate an environment variable. So this variable will effectively provide the connection string to that database to the running workload on my cluster. That is all done in the manifest. So let's go ahead and deploy it. Deploy the manifest to .yaml. We have 2 new things. We have the DB workload, and we have those parameters. Right, so this is going to take a little longer because we will now be creating an actual Postgres RDS database in AWS. So this is going to take a couple of minutes, but we can use the time to look around a little bit. If we go to our AWS console right at this moment, cool, we now see that there is a new database instance in status creating. if we look at the actual module definition while we're at it, let's go back to our orchestrator. So the Postgres module, again, is very, very simple. It is this piece of code. And just like the Kubernetes workload module earlier, this wraps a module source that is provided somewhere on a Git repository. We could also have an inline version of that, but usually you want to have it in a maintenance in a separate Git repository. So this is essentially all it does. This is the module, and we're starting the orchestrator where to find it. And by doing that, then the runner will check out this code and use it to perform a TF apply, which will then effectively lead to this database being created. So again, we are now here. We have done some more instructing by adding the module for the database. So we added to this configuration estate of the orchestrator. We then performed another deploy with an extended manifest where we said, okay, on top of having this Kubernetes-based workload, I now also want to have a Postgres database. And the new runner took the combined module code from those two modules, so the Kubernetes-based workload and the Postgres database, combined it into an aggregate piece of Terraform code, and is currently applying it. So what we get is then the workload running on the Kubernetes cluster in our case, and another resource, which is new, which is the RDS Postgres on AWS. So let's see where we are. This is still being created. This can take a while, but we can already go ahead. This is the code that is behind the module. So we just saw this Git reference, and this is just the code that we have. It's a very, very simplified version of an AWS RDS Postgres instance. This is literally what is currently being executed as we speak. It's a publicly available database. So again, no production ready setup right here, just for demo purposes, but this will serve our purpose just fine. Right, when we are done, we will have a resource graph that is being extended like this. Let's go back to our project environment and see if we already have it. Yes, we do. Cool. So our resource graph has now been expanded. We have the KTS workload as before, and we also have this Postgres database. It is not complete yet because I'm not seeing the metadata that I'm expecting. That is probably because the deployment is still ongoing. Yeah, from experience, the RDS database usually takes like 4.5 minutes to set up. So there is little we can do to speed this up at this point, but let's just come back to it when it's done and continue at the moment. However, there's not much to continue to because this is basically the end of the tutorial. However, we're going to clean up as our last step because the orchestrator is also able to tear down all the things that you just deployed. So what we're going to do as the cleanup step is we go to our project, and you have a project environment. Then all the resources that have been deployed into an environment through the manifest, so in this case it's the workload and the database, they will be destroyed when you destroy the environment. So a destruction of the orchestrator object of this orchestrator environment will lead to a Terraform destroy of all the resources that were created for that environment. So the life cycle is being passed through, as it were. So you have the orchestrator as your entry point to not only create, but also tear down environments as you like it. This is especially interesting for temporary environments that you might want to set up for your software development life cycle. Like you can, for example, you can set up a temporary environment for a feature branch for your application, provision all the resources that you need through the orchestrator, and then tear it all down again in a very, very controlled fashion. It is literally one command that you need to launch to the orchestrator, and it will tear everything down again. Right, finally, it has been done. Let's go back to our AWS console. This is now available. And if we go back to our resource graph, click this resource again, we get some metadata right here. So we now see, we now got some information where this instance is actually running, which region, what is the ARN, what is the database called, and we even get a link as a convenience feature that we can click, and it takes us to the portal, or in this case, the AWS console, to show us our instance. Nice. So that worked. And the last thing is doing the cleanup. However, I see we're almost out of time. So just believe me when I say that the destruction of the environment, I'm in the wrong directory. There you go. So the destruction of the environment, orchestrated environment development is destroying. And if we go to our console, this should now switch to a status of deleting. And that's the last thing. There you go. This is now deleting, and the rest of the setup will be deleted as well. So this is the last thing I'm going to show you because we are at the end of our time. I'm going to stop my screen share now and be available for questions for another 2 minutes.
Yeah,
So
we have a number of questions here. Can you see them?
Yes, I can. So one question is, what is the recommendation or ability for Humanitec to be able to add additional service accounts to a shared RDS instance? What about permissions? Is it something can ensure privileges to be maintained? Yes, and that is actually a very good practice and a very good point. You saw that we have the capability to provide standardized modules for your estate. So the Terraform code for the Postgres that we just saw can include anything that you wish to provision along with the database, which can be IAM permissions, roles, all those sorts of things. And they will be automatically provisioned along with the database every time one such thing is provisioned without the developer noticing. And that's the cool thing. The manifest will not change. You will still have the same 2 lines of code in the manifest where your developer says, I need this Postgres. And all the things that you put into your backing code, be it permissions, networking, rules, anything, will be provisioned automatically. So that is a way to standardize your estate and to roll out your security posture and roll out your security standards in a very controlled way. That is one of the core tenets of using an orchestration like this. And is there a mechanism to detect infrastructure drift? There will be. We do have the state, we do have the Terraform state for every environment that has a deployment available to the orchestrator. So we essentially have the capability to run this state against the real setup out there. It is not implemented yet, but it is on a roadmap to provide exactly this config drift detection, because we have all the information that we need, and we can periodically run a comparison of the state that we know and the state of the real world and provide this config drift detection. It will be added to our product, it's just not there yet. And a related question was to push out force upgrades to avoid AWS's expensive support fees. Yes, that is another thing we can do. So right now what you saw is the proactive deployment into an environment on behalf of the developer. But we also have plans to say, hey, this module definition has changed, or the code behind the module definition has changed. Please update all the resources in the module definition. It's not exactly trivial, to be honest. So this is why we haven't implemented it in the first shot, but it's also something that is on our roadmap.
Fantastic. Are there any other questions for Toby for the time being? If not, it's great to see so many of you here. If you can always head over to humanitec.com and try this yourself. We will also send a follow-up email where you get the link to the tutorial. And we and our colleagues on the support team are always happy to help you if you are stuck somewhere. And we very much welcome feedback to this version that is rolling out over this quarter now. So if you have any ideas, any feature requests, you want to, test this, you have certain things that you would want to deep dive on, just let us know. We're very happy to facilitate that. Yeah, well then with that, Toby, thank you so much for your time tonight. And
Thanks everyone for coming.
Thank you to the demo gods for being with us, everything working flawlessly. And see all of you very soon.
Cheers. All the best.
Bye.